comprehensive sampling system for ferroalloys. Ferroalloys form an essential raw material in steel making, and the most commonly used are ferrovanadium, ferromolybdenum, ferrosilicon, ferrochrome, and ferromanganese. The alloys are commonly supplied in jumbo bags carried in trucks. Out of several trucks carrying ferroalloys, a few trucks are selected at random for sampling. From each truck, 3 jumbo bags are picked at random. These 3 bags of 1 ton each are processed in the system one after the other. The ferroalloy material is received with a maximum input size of 70 mm. To begin with, details of each lot or sublot are registered in an inward register for material identification. These registration details are also entered in the identity tags attached to the trolleys. Each jumbo bag of 1 ton is lowered by a mobile crane on a receiving hopper where it gets punctured by a piercing cutter. The received material is fed by a vibrating feeder onto the conveyor. A provision for manual sample feeding is also provided. Here, approximately 25 kg bags are kept on a table, manually punctured and emptied onto the conveyor. The conveyor lifts the material and feeds it through a second vibro feeder into a special sample divider which is programmed to handle 1 ton material in about 10 minutes. The sample divider contains a rotating bucket which collects the representative sample at periodic frequency from the falling stream. This sample divider collects approximately 150 kg material in several increments and feeds the material into vibratory screens for sieving. The material passing through the primary sample divider passes through another sample divider where 7 to 9 kg material is drawn in several increments and collected into a mobile trolley for chemical analysis. After all 3 jumbo bags are processed, approximately 25 to 30 kg material is collected in the mobile trolley. The discard material from both the sample dividers is about 840 kg, which is dumped in a discard bin. Approximately 450 kg representative sample material is collected and subjected to sieving on the multi-deck vibrating screens. Different size fractions are segregated and collected in separate bins. The large fraction is carried in a separate trolley, while the 3 smaller fractions are carried in a single trolley. The individual size fractions are separately weighed and their particulars recorded by the operator. This completes sample roll and sieving operation. The operator then carries approximately 25 to 30 kg sample along with the sample identity tag to the sample preparation section where the tag details are recorded into the logbook. The mechanized sample preparation cycle begins with feeding the entire 25 to 30 kg of representative sample material into the specially designed slotted conveyor, which uniformly feeds the material into the vibrating hopper of the primary jaw crusher. The unique action of tungsten carbide lined jaw blades crushes the sample material to -12.5 mm size. The crushed sample falls into an inbuilt sample divider to obtain a representative sample quantity of 3 kg while the remaining sample is discarded. The representative sample is conveyed into the secondary jaw crusher where it is crushed to -5 mm. The sample is further divided in a falling stream sample divider to obtain the desired quantity of about 120 grams. The balance material is disposed of in the discard material bin. This completes the crushing operation. The representative sample of approximately 120 grams is then fed into the vibratory cup mill for pulverizing. The VCM grinds the sample to -100 mesh in about 3 minutes. The ground sample is emptied by the operator in a tray and 3 parts of 40 grams each are prepared by the weighment. These separate parts are filled in bottles which are labeled by the operator for identification purposes. The first bottle is sent for XRF and carbon sulfur analysis, the second is referee sample, and the third is handed over to the supplier. This completes the pulverizing operation. The entire size analysis and sample preparation process can be smoothly performed by a single operator very easily. Insmart's automated sieving and sample preparation system is designed to provide repeat accuracies in sampling processes and remove the need for a person to carry the sample to the processing unit and to put large quantities of discard samples to the yard. Thus, Insmart's sampling solutions are highly reliable, help customers in saving time, and provide much faster payback time. Here is a bird's eye view of the entire system.